Sorry about that. Sorry, that's okay.
All right, welcome everyone to the Hacker Mansion. My name is Eva. I am the student engagement lead from the Algorand Foundation, and it's a pleasure for me to welcome you all here in Denver. So, we are starting this presentation. We are super happy to have you here. Well, this is the program that we prepared for you all. First, we will learn how to build on Algorand using AlgoKit. Well, AlgoKit is an amazing tool we are performing. We are innovating the entire ecosystem, and we are super excited to share to you all. Then we will have a challenge. It's a completed coding challenge, and we will share with you the certificate. You don't need to complete that by today, but we will be very excited and very happy if you all complete by in the next few days. And then we have a surprise for you. We will learn about DeFi with Fox Finance. We have Ibu, who represents the project. It's one of the most amazing DeFi projects that we have at the moment in the Algorand ecosystem. And we will share the do's and don'ts, how to build a DeFi project. And then, of course, we will be sharing you how you can join our vibrant community and how you can be part of this amazing ecosystem. If you're a student, if you're a developer, or just you love crypto, you are welcome to join. And then, do you have an Algorand wallet? If you don't, I encourage you all to download our Pera wallet and claim our Plaus. Plaus is an application, is an NFT that represents the proof of attendance, but in Algorand. You have a different feature here that you can download it on Web 2 just using your Gmail, or you can download on Web 3 using your Pera wallet. I encourage you all to test it and try it because it's super fast, super smooth. I'm sorry, I am moving a bit. So you can have your NFT on Algorand. This is a pretty cool design. We worked hard on this. We hope you like it. And of course, enjoy how fast is our blockchain. I will give you a couple of minutes. You have to scan it with just your camera. And with your camera, you will see a link to Go Plausible application. And then after, if you need some support, or if you want the QR code again, I can share with you, of course. So now, time for having fun. Now I would like to introduce to you our two amazing developer relations that we have in our ecosystem, Joe Polny and Chris Kim. Please welcome.
Hello, thank you so much for coming, everyone. All right, so before we start, let's see a show of hands. Raise your hand if this is the first time you're learning about Algorand. First time? Okay. Let's see a hand if you're a developer. Oh, amazing. Love it. Okay, well, if this is your first time learning about Algorand and if you're a developer, then you're at the right place. Now, when you come to a new blockchain, especially non-ETH, it's like coming to a new country. You don't know the culture there, you don't know the food, and everything is very foreign to you. So it can be very overwhelming and daunting to start that new learning journey, which prevents a lot of developers to venture into other different blockchains and learn it because they think that it's going to take too much time or it's just not going to be worth it. Well, that's why we're here today. Within this hour and a half presentation, we're going to cover everything from what the Algorand protocol is, what the differences is between Ethereum and Algorand, the smart contract language and the developer tools we have, and also a complete code demo of building an application. Is my mic coming through okay? Awesome. Hello everyone, my name is Chris Kim. I'm a developer relations advocate for the Algorand Foundation. And we have Joe Polny here, who's also my colleague, DevRel engineer, and he's also the creator of TealScript, which is the JavaScript-like smart contract language on Algorand. Now let's start with the million-dollar question. What is Algorand? Algorand was founded in 2019. Well, the mainnet started in 2019, and it was founded by Sylvia McCauley, who is an MIT professor and a Turing Award winner in cryptography. For those of you who don't know what Turing Awards is, it's basically Nobel Prize for computer science. So it's the highest level of achievement you can get on the field. He's also the co-creator of zero-knowledge proof, which is a cryptographic method that is being highly used and studied right now for blockchain scalability. He also created a verifiable random function, which allows you to get pseudo-random values in a verifiable manner. Now, we'll come back to VRF later on because it is heavily used in the Algorand protocol. Back in the days, Vitalik Buterin has said all blockchain needs these three things: decentralization, scalability, and security. But he also said you can't have all three. You gotta sacrifice at least one. He called it the blockchain trilemma. Well, Sylvia McCauley disagreed with this claim, and he said that the Algorand blockchain has solved the blockchain trilemma. Now, I know where your head is going when you hear that. It sounds fake. It's always a catch. So let's dive into each one of these components and see how Algorand excels in all three of them. So let's first start with blockchain security. Is Algorand secure? When we say blockchain is secure, it means that the data that is stored on the blockchain is both permanent. Do you hear me? Awesome. Yeah. So when we say a blockchain is secure, we mean the data that is stored on the blockchain is both permanent and authentic. Now, for data to be permanent and authentic, the process that adds the new data to the blockchain has to be secured and decentralized. So how is Algorand secure? We use this unique consensus protocol called pure proof of stake. And this is the protocol that is securing the Algorand blockchain. Now, when Sylvia created Algorand, he didn't want to use the popular proof of stake consensus protocol like delegated proof of stake because he didn't believe those were decentralized enough. For example, delegated proof of stake, the way it works is the entire network, they don't participate in consensus, but all they do is they delegate their tokens to a small group of computers that actually participate in consensus. Now, the problem is, because there's only a small group of nodes that are actually doing the work, that itself can be centralized. And two, these group of nodes are pre-known to the public. So it creates a possibility of attack vectors, bribing these group of nodes. So it could compromise the consensus process. So Sylvia came up with this unique consensus protocol. He wanted a more decentralized and more pure way of achieving consensus. So here's how it works. I'm going to leave out a lot of technical details, but for every consensus round, there's 3 stages. The first stage is called block proposal. Now, at the first stage, the VRF, the technology that can get random values, goes to the entire network and randomly select a group of nodes to propose a block. So we have multiple blocks proposed by these nodes. And then we move over to stage 2, which is called soft vote. Now the VRF goes to the network again and randomly selects another group of nodes to form a committee. And this committee reduced that multiple block proposals down to 1. And then we move to stage 3, which is called certified vote. In stage 3, The VRF again randomly selects another group of nodes to form a committee, and that committee votes whether this block proposal is valid or not. If it's valid, it gets added to the blockchain, and the process repeats itself. So that's how consensus is achieved on the Algorand blockchain. So why is this securing the Algorand the blockchain? Remember, I said that the VRF chooses these committee from the entire network. Now, everyone who have at least 0.1 algo, which makes the account a valid Algorand account, and just say, hey, VRF, I want to participate in consensus, the VRF consider them when it's randomly selecting these nodes. So the entire network can participate in consensus, therefore making this one of the most decentralized way of achieving consensus. Another reason, when this selection is happening, it's random selection using the VRF. And because it's random, everybody has a chance to participate in consensus. Peer proof of stake also allows instant finality on Algorand, and this is one of the most powerful features that the blockchain provides. But remember, by stage 2, we said that the committee reduces the number of block proposals down to 1. So during the consensus round, you only have 1 proposal to consider. So there is no chance for 2 blocks to be added to the blockchain at the same time, which is a possibility in a lot of blockchain protocols out there, like Ethereum. So because there's only 1 block proposal, when a block is added to the chain, it is instantly final. No data on the chain will ever have a possibility of rolling back. So you can trust that all data recorded on the chain is permanent and authentic. And we also took the first step into making Algorand blockchain post-quantum secure. So we use this technology called state proof. And state proof uses a post-quantum security cryptographic method called Falcon key to create a proof of the state of the blockchain. So now the entire history of the Algorand blockchain is post-quantum secure. Now, I'm not saying we have 100% post-quantum security, because transaction signing is still not post-quantum secure. So if quantum computing came around today, all incoming transactions to the block won't be post-quantum secure. But at least we know that from this point and before to the Genesis block, the entire history is post-quantum secure. I'm telling you this because we are dedicated to security, and we already made the first step into making Algorand future-proof. And our track record shows this. The mainnet's been live since 2019 for over 4 years, and the Algorand blockchain has never experienced downtime. Now, I'm not saying Algorand will never go down, because we're constantly upgrading the protocol, and software is bound to have errors and bugs. But I'm saying, 1, the design of the Algorand protocol is so robust that it hasn't witnessed downtime yet, and 2, the core protocol developers are dedicated to this mission to continue to keep the Algorand blockchain available 24/7. Okay, so Algorand is, I'll take questions after the presentation. Thank you. So, Algorand is secure, but if we're talking about blockchain security, you can't leave out decentralization. So, is Algorand decentralized? Now, whenever we talk about protocol decentralization, everybody has different definitions and different thoughts, and it often becomes an ugly debate that nobody gets out of. So here I'm intentionally limiting to these 2 topics. When I say a blockchain is decentralized, I mean the consensus process is decentralized, and also the ledger is decentralized. I've already said that peer proof of stake is one of the most decentralized ways of achieving consensus because it includes the entire network. And I'm not just saying this. This is a Twitter account that automatically posts every day who the top proposer is and the smallest proposer is. And on January 30th, 2024, the smallest block proposer has 0.1 algo in their wallet, which is the smallest amount of algo they can hold. So this really shows you the power of peer proof of stake, that everyone is involved in the consensus process. Now moving on to the second point, it's got to have decentralized ledger. For the ledger to be decentralized, you got to have a lot of computers storing the same record. That's what makes it decentralized. And for that to happen, it has to be cheap and easy to run a node. So the foundation has released a one-click node where it makes it super easy to set up a node on your computer or on any hardware that you want. We also have community-made one-click nodes that you can use if you prefer, but it is continuously getting improved, so it is super easy to run a node on Algorand. Also, it's cheap to run a node. Unlike Ethereum, where you have to stake a lot of ETH, there is no minimum stake to be participating in consensus. You only need that 0.1 algo that makes your account valid, and you're good to go. Now, Algorand is not perfect, and it has its fair share of criticism. And the main criticism comes around, is Algorand decentralized? And these are the two criticisms. Some people say Algorand is centralized because it relies on relay nodes. Another criticism is that the Algorand blockchain currently doesn't incentivize nodes for participating in consensus. So let's see what's going on. Currently, the Algorand network has this structure where participation nodes that participate in consensus don't talk to each other directly. They have to go through relay nodes that relay the messages. Now, these relay nodes, all they do is they relay messages and they don't participate in consensus. So when it comes to consensus, it doesn't affect the decentralization. But here's where the problem comes in. Relay nodes are expensive to run, so not everyone can run them. And also, currently, the group of relay nodes that are on the network were pre-selected by the Algorand Foundation. And this is where a lot of people get angry, that the foundation has control of the network, oh, this is not decentralized, or they can prevent my transaction from going through if they don't like me. Now, I want to clarify, if you really care about this, and if you really don't want to use relay nodes that were pre-selected by the foundation, you can run your own relay node and configure your participation node to only talk to your relay node, therefore circumventing the pre-selected nodes. But still, it is a valid criticism. So we are actually going to be moving away from relay nodes and making them optional in the future. So we're going to be implementing a peer-to-peer gossip protocol where the participation nodes talk to each other. And relay nodes will still be there, so if you choose to use them, you can do so. But in the long run, the plan is to completely remove relay nodes. Now let's move to the second criticism, where nodes are not incentivized to participate in consensus. Now, the reason why this is the case is because when Sylvia created Algorand, his theory was that voluntarily run nodes if they care about the security of the chain. So if you are building your product on the Algorand blockchain, you will run a node because you would want that chain to be secure. It's kind of similar to how people are planting trees to make the Earth a healthier place, because we live on Earth. But we're actually going to be moving away from this initial theory that Sylvia had and be introducing node incentivization. So when this goes live, every Algorand node that participates in consensus will be rewarded for their work. So we have this beautiful roadmap called the Algorand Gambit. And in 2024, these two protocol upgrades are planned to go live. And the consensus incentivization upgrade will come with the Ready upgrade. And the peer-to-peer gossip network upgrade will come with the Capablanca variation upgrade. Now, there's an open discussion about these upgrades on GitHub. So if you want to share your insights or just get involved in that discussion, you can head to our GitHub repo and share your insights there. Okay, so now we know that the Algorand blockchain is both secured and decentralized. But usually when the blockchain has those two things, it's slow. And the reason why it's slow is because when the blockchain is decentralized, you have more nodes that you need to talk to achieve consensus. Therefore, it's slow. So let's see how Algorand solves this problem. And we come back to our unique consensus protocol, pure proof of stake. And remember, pure proof of stake involves the entire network to participate in consensus. But how can we achieve that fast speed if the entire network is involved? Well, remember, the group of nodes that actually do the work during the consensus round were randomly selected by the VRF, and there's only a small group of nodes that are actually doing the work. So although the entire network is considered to participate in consensus through random selection, the actual work is being done by only a small group of nodes, therefore allowing you to achieve both decentralization and scalability. So how fast is Algorand? When we talk about blockchain speed, we usually talk about these three metrics. Is it better if I come over here?
No, I'm going to give you a viral mix so there's no will work. That's yeah, thank you.
There we go. Are we good?
Yeah.
Awesome. So these are the three metrics that we talk about when we talk about blockchain speed. TPS, which is transaction per second, so how many transactions that the blockchain can execute per second. We have block time, which is the time it takes for a newly proposed block to be added to the blockchain, and time to finality, which is the time it takes for the added block to become final. So Algorand currently can handle up to 10,000 TPS. It has about 2.8 second block time and has instant finality. Now let's touch a bit more on the instant finality part, because a lot of people get confused and angry about this. They say, oh, you can't execute a transaction instantly. That's just physically impossible. We're not saying that. There's still that 2.8 second block time. But we're saying that when the block is added to the chain, it is instantly final. So let's explore this concept a little bit more. On a lot of blockchain protocols, there's a possibility for two blocks to be added at the chain at the same time, by chance. And when this happens, now the one source of truth that the blockchain record had is divided into two. So the entire network now have to make a decision which one of these chain is the true chain. So as time goes by, they all make a decision and they build on the chain that they think is the true chain. And as time goes by and when this becomes apparent, the shorter chain gets invalidated and all of the transactions that were included in the shorter chain gets rolled back. Now, because this is a possibility, these blockchain protocols usually recommend you to wait around 6 or 7 blocks to be 100% certain that your transaction went through. So if you're talking about Ethereum, it currently has a block time of 15 seconds. If you're waiting 6 blocks, that's a minute and a half that you have to wait to be 100% certain. And that's in the best case scenario when the Ethereum blockchain is not congested. On Algorand, your transaction will go through, get executed, and be final in 2.8 seconds all the time, thanks to its finality. Now let's talk about some unique Algorand features. ASAs. ASAs stand for Algorand Standard Assets. Now, unlike Ethereum and a lot of blockchain out there, tokens on Algorand are not smart contracts. So on Ethereum, fungible tokens are ERC20, NFTs are ERC721, and they're all smart contracts. You have to deploy a smart contract to create tokens. Well, in Algorand, all you need to do is send an asset creation transaction to the network, and boom, your token's created. No contract needed. Now, there are 2 benefits that come from this. One, you don't need a smart contract, so you don't need to audit your smart contract, and there's also no chance of including a security vulnerability to the contract. Because every smart contract, you can either accidentally or intentionally include security vulnerability, causing a lot of people to lose money. Well, with ASAs, as long as the Algorand blockchain is secured, your token is safe. Second benefit, it prevents reentrancy attack. So reentrancy attack is one of the most infamous attacks that live on Ethereum, and it exists because every time a smart contract is dealing with tokens, it's got to make an external call to that token contract and call that transfer from method. Now, when you're making this external call, you're calling a contract that you have no control over, and you're taking a risk. And because you have to make that external call, and once that's finished, it comes back to the smart contract and continues the logic, that introduces the reentrancy attack. And if you are not careful as a developer, you could be causing a lot of problems. Well, with ASAs, because it is just built into the protocol, there's no problem regarding that. Atomic transfers. Now, when you're building a blockchain-based application, it usually includes a trade between 2 parties. Now, blockchain is a trustless environment. There is no intermediary that's going to ensure that the trade happens in a fair manner. So, for that trustless trade to happen in a fair manner, it's got to happen at the same time. For example, I want to buy a PS5, but it's all sold out. So I find this shady website, I find this seller that's selling a PS5 for $300. I say, hey, I want to buy this PS5. And he's like, yeah, sure, just send me the $300 and I'll send you the PS5. So I send him my $300, a couple days goes by, no, he just disappears, and I lose my $300. This is a problem because I had to trust that the seller will send me my PS5 because that didn't happen simultaneously. So simultaneous transactions is very important in a blockchain environment. For blockchain protocols that doesn't provide this natively, you have to come up with complex logic like hash time lock contracts to make this happen. But an Algorand is just right, you can use this right out of the box. It's very easy to group multiple transactions and execute them at the same time. Algorand is not an EVM chain. It uses this unique virtual machine called Algorand Virtual Machine. But Silvio created Algorand. He said this in one of the conferences he attended. He said that the blockchain industry is so early that if we decide on a standard at this stage, we will be limiting the potential of this technology. So Silvio wanted to do something more than what the EVM enabled back in the day. So when he was creating Algorand, he created a separate virtual machine called the Algorand Virtual Machine. The AVM understands this smart contract language called TealScript, which is a low-level assembly language. Now, you as a developer won't be directly working with TealScript. There's a higher-level language, so don't worry. But that's what the AVM understands. The AVM currently provides more than 180 opcodes, which is more than what EVM provides. It can handle up to 512 bits of mathematical accuracy, so you can deal with larger numbers when you're doing mathematical operations. It also allows smart contracts to send transactions, and we call them inner transactions. Okay, now let's talk about how Algorand is different from Ethereum. And the reason why we're doing this is because if you're a Solidity developer, we want you to bring the knowledge that you already have and just leverage that when you come to Algorand. You don't have to start from scratch. If you know what's different, as long as you know that, you'll be able to apply the knowledge that you have. So that's why we're doing this. On Ethereum, gas fees are dynamic, and it changes based on the congestion of the network and how complex your transaction is. On Algorand, transaction fees are always fixed to 0.001 algo. And that's 0.001 algo for a simple payment app, a transaction, and a complex smart contract call. But there are two cases when this goes up. One, if your smart contract call is so complex and opcode heavy that it exceeds the opcode limit. When that happens, you have to group two smart contract calls together to make that happen. So the transaction fee would go up to 0.002 algo. Another case is when the blockchain gets congested. So for some reason, if the TPS exceeds 10,000, the node will pick up whoever had the highest transaction fee. Gas fees on Ethereum are always paid. So if your transaction fails for whatever reason, you're still paying that gas fee. You're not getting that back. Is it small now?
It's less than the full.
Less than the full amount,
Yeah.
but you're still paying, right?
Yeah.
It stops at the failure, basically.
Yeah, that's awesome. Because back in the days, it was just paying the full amount, right? Nice. On Algorand, you only pay your transaction fees when the transaction gets executed. So you as a user, when you're using Algorand-based applications, you don't have to worry about wasting transaction fees. If it fails for whatever reason, your algos are never leaving your account. But that's good information. Thank you for letting me know that. Tokens. I mentioned this before, so I'll mention it briefly. Tokens on Ethereum are smart contract based. Tokens on Algorand are built into the protocol. There are two types of accounts on Ethereum. Externally owned accounts, so EOAs, and contract accounts. Externally owned accounts are accounts that users have to interact with smart contracts and with the Ethereum blockchain. And contract accounts are smart contracts. So smart contracts on Ethereum are all accounts. So they can receive and send assets and send transactions. On Algorand, there's only one type of account. It's called Algorand accounts. and it's like EOAs on Ethereum. But what about smart contracts? So Algorand smart contract itself is not an account. So it doesn't have a unique identifier as an address, but it has an app ID, which is just a number. But all Algorand smart contracts are linked to an Algorand account. So it can do the same thing that the Ethereum smart contract can do. But let's see this example to really understand what's going on here. Let's say we have an account A that is calling this deposit function defined inside of smart contract B. I'm going to use this. Now, this deposit function is a simple method where you're sending a certain amount of algos to the smart contract and it's updating the balance. You're not directly sending that algo to the smart contract because this is not an account. So you're atomically grouping a payment transaction and sending it to the linked application account. So that's what's happening. So that's something that you have to understand as a developer when you're building an application on Algorand. But at the end of the day, you can do the same thing that you can do on Ethereum. Smart contract storage. Currently on Ethereum smart contracts, the way you store is within this giant 2 to the 256 slots, where each slot is 32 bytes each. You can store all types of data types like arrays, strings, numbers, and if it goes beyond 32 bytes, it gets divided into multiple slots. Now, when you're deleting these storages, you actually only get 50% of that storage feedback. And I was really intrigued when I was researching this. And the reason for this is because whenever you send a storage deletion transaction, the nodes are the